Imagine the solar system as you first learned it, the Sun at the centre with planets neatly orbiting around it. This familiar image ends abruptly after Neptune, leaving an impression of emptiness beyond. But this view is misleading, hiding the vastness beyond the charts. Beyond Neptune lies a realm so expansive that it dwarfs the planetary zone we know. The solar system, as depicted in textbooks, is just a fraction of the story. The Sun, a colossal sphere of hydrogen and helium, dominates the solar system by mass. It contains nearly all the material, with planets and smaller bodies making up a mere fraction. Mercury, the nearest planet at 36 million miles away, orbits at about 0.4 astronomical units. An astronomical unit, the mean distance from Earth to the Sun, quantifies celestial distances, a unit we will revisit. Venturing outwards, we encounter the inner rocky planets, Mercury, Venus, Earth, and Mars. They cluster within 1.5 astronomical units close to the Sun. These worlds, solid and dense, offer harsh conditions, from Venus's crushing pressure to Mercury's extreme temperature swings. Beyond Mars lies the asteroid belt, often misimagined as a dense cluster of rocks, when it's truly a sparse field with vast spaces between asteroids. Moving further, the giant planets stretch the solar system's scale. Jupiter, at over 5 astronomical units away, is immense, with a volume that could contain 1,300 Earths. This gas giant shapes the orbits of many solar system objects, including comets, acting as a guardian of sorts for our planet. Saturn, orbiting nearly 10 astronomical units from the Sun, is celebrated for its iconic rings. These rings, though expansive, are surprisingly thin, composed of ice and rock fragments. Saturn's moon, Titan, captivates with its thick atmosphere and lakes of methane. If you find this exploration intriguing, consider liking or subscribing. Your support means a lot. Let us look a little closer. Beyond these planets, the solar system continues to unfold, revealing mysteries that challenge our perception of its true scale. The vastness of the solar system truly comes into focus when you peer beyond Neptune. Imagine a space starting at about 30 times the distance from the Earth to the Sun, stretching out to 50 times that distance. This is the Kuiper Belt, a sprawling region filled with icy relics from the solar system's youth. Unlike the rocky debris of the asteroid belt, the Kuiper Belt harbours remnants composed of ice and rock, preserving the primordial mix of the outer solar system. Among these icy bodies, Pluto once reigned as the 9th planet, but in 2006 it was reclassified as a dwarf planet due to its inability to clear its orbit of other debris. When NASA's New Horizons spacecraft reached Pluto in 2015, it revealed a fascinating world with towering ice mountains and vast nitrogen plains. And yet, Pluto is just one of many. The Kuiper Belt is home to thousands of such objects, with many more likely hidden in its depths. Take Eris, for example. Discovered in 2005, this dwarf planet is slightly more massive than Pluto, and played a key role in reshaping our understanding of what constitutes a planet. Its discovery prompted the creation of the dwarf planet category, acknowledging the multitude of large bodies in the Kuiper Belt without endlessly expanding the list of planets. The story of the Kuiper Belt's discovery is one of gradual revelation. In the early 1990s, astronomers David Jewett and Jane Liu confirmed its existence with the finding of a small object orbiting far beyond Neptune. This discovery, along with others, showed that this region was far from empty. It is a vast collection of frozen bodies, each a time capsule from the solar system's formative years. At 50 times the distance from Earth to the Sun, light takes nearly 7 hours to reach these objects. Here, the Sun is no longer a disk but a brilliant point of light. The temperature drops to a bone-chilling negative 370 degrees Fahrenheit, freezing these bodies solid for billions of years. They hold secrets from a time when the solar system was still a swirling disk of gas and dust. As you contemplate these remote regions, you begin to appreciate the solar system's true scale. Beyond the familiar planets lies a vast and icy frontier, where the sun's influence wanes but never entirely disappears. This frozen realm challenges our perceptions and invites us to ponder the mysteries waiting in the vast, dark spaces between the stars. Beyond the icy frontier of the Kuiper Belt, a new mystery unfolds. For a time, many thought this belt marked the boundary of our solar system. But that assumption was entirely misplaced. The Kuiper Belt, stretching from 30 to 50 astronomical units from the Sun, is just a thin slice of a much larger domain. Beyond it lies an expanse of space still under the Sun's sway. Imagine this. The Kuiper Belt's farthest reaches are where our direct exploration ends, where telescopes strain to see the faintest objects. Yet this is merely the beginning. What lies beyond sends us messages in the form of comets. These icy wanderers, often called dirty snowballs, become visible when they near the Sun. The heat causes their ice to vaporize, forming a glowing coma and a tail that always points away from the Sun, pushed by solar winds. Comets have captivated humanity for millennia. Seen as omens in ancient times, now we understand them as ancient relics, preserving the solar system's primordial material. But their orbits reveal more. Short-period comets, like Halley's, stick close to the plane of the planets and likely originate from the Kuiper Belt. The occasional gravitational nudge from Neptune can send them sunward, lighting up their icy surfaces. However, not all comets follow this neat pattern. Long-period comets defy expectations, with orbits extending thousands, even millions of years. They arrive from all directions, not confined to the plane of the planets. This randomness suggests they emerge from a place far beyond the Kuiper Belt. An astronomer once scrutinized these erratic orbits and realized they hinted at something vast and unseen. This realization transformed our understanding of the solar system's scale. The solar system, once depicted as a flat disk with planets neatly orbiting, is actually a sprawling sphere. The Oort Cloud, a hypothesized shell of icy bodies reaching up to 100,000 astronomical units from the Sun, is the source of these long-period comets. Though invisible to our eyes, the Oort Cloud reshapes the boundaries of our solar system. It extends the Sun's influence to nearly a third of the distance to the nearest star. As we unravel this cosmic enigma, we discover a solar system that is far more expansive and complex than our textbooks ever suggested, inviting us to rethink our place in the universe. Yet what Jan Oort proposed in 1950 reshaped our understanding of the solar system's vastness. In a world still recovering from war and entering the Cold War's shadow, Oort's quiet contemplation in the Netherlands was revolutionary. Without the aid of a new technology or discoveries, he used the power of thought and careful analysis of comet orbits to propose something astonishing. Imagine a sky full of comets, their paths traced and catalogued by astronomers. Short-period comets were understood, orbiting predictably in the same plane as our planets. But long-period comets defied this order, arriving from all directions, with paths stretching far into the unknown. Oort noticed a pattern. Many of these comets reached their farthest points from the Sun at distances between 20,000 and 50,000 astronomical units. This wasn't random. It hinted at a structured source of these icy travellers. Oort realised that these comets must come from within our solar system, bound by the Sun's gravity. A vast spherical shell of icy bodies, the Oort Cloud, must encase the solar system. But why was this cloud necessary? Think of the solar system as a dynamic interplay of gravitational forces. Each comet, as it swings close to the Sun, risks being altered by the giant planets, especially Jupiter. Over time, such interactions should have depleted the comet supply, yet comets persist, hinting at a replenishing source. The Oort Cloud, Oort proposed, could contain trillions of icy bodies. These distant objects orbit so slowly that they remain untouched for eons, until a disturbance, perhaps a passing star's gravity or the pull of the Milky Way, sends one hurtling toward the Sun. As it approaches, the Sun's warmth transforms it into the glowing spectacle we recognise. This journey, from the far reaches of the solar system to the inner sanctum, can take millennia. Oort's hypothesis, published and swiftly accepted, named the Oort Cloud in his honour. Each new comet, each unexpected visitor from the depths of space, adds weight to his vision. Comets like Hyakutake, which graced our skies in 1996, remind us of this distant, mysterious realm. They invite us to ponder the solar system's true expanse, stretching our imaginations far beyond the familiar planetary orbits. As you drift into sleep, consider these celestial travellers, messengers from the edge of our solar neighbourhood, whispering the secrets of a universe both vast and intimate. These celestial visitors, like comets Hale-Bopp and others, remind us of a vast hidden structure far beyond the planets. Hale-Bopp, one of the brightest of the 20th century, painted our skies for 18 months, reaching into the solar system's outer limits. Yet the true marvel is not just their beauty, but what they signify. They are evidence of the Oort Cloud, a colossal sphere of icy bodies that stretches the solar system's boundaries far beyond what we can see. Imagine this. We have never directly observed the Oort Cloud. No telescope, no spacecraft has captured its elusive form. These objects are far too remote, too faint for our current technologies. Picture a few small lumps of dark ice and rock, each one tens of thousands of astronomical units from the Sun. At these vast distances, even the largest among them would be billions of times too dim to spot. Instead, we infer their existence through the comets that journey past us. Visualize detectives reconstructing an unseen crime from scattered clues. The comets are our clues, the Oort Cloud is the conclusion we draw from them. This scientific deduction is both humbling and awe-inspiring, as it reveals an immense structure we cannot physically observe. So, what would the Oort Cloud look like if we could see it? Surprisingly, it would appear almost empty. Unlike the dense rings of Saturn, it is a sparse scattering of icy bodies spread over an enormous volume. Imagine standing in its midst. You'd see nothing but the usual darkness of space, not a hint of the trillions of icy objects surrounding you. These objects are scattered so thinly that the nearest might be billions of miles away, indistinguishable from the stars. The term cloud is misleading, it is more like a sparse array of sand grains on a continent-sized space. Consider this. The Oort Cloud may contain between several 100 billion and a few trillion icy bodies, each over half a mile across. Yet these objects occupy such a vast space that the average distance between them could be close to 1 billion miles. Even if we shrunk this structure down, the closest grains of sand would still be miles apart. It is overwhelmingly empty, yet its total mass might be substantial, possibly up to 40 times Earth's mass, made mostly of ice mixed with rock and dust. But how did these icy bodies end up so far out? The early solar system was a crowded field of planetesimals, small icy bodies orbiting near the giant planets. The gravitational forces of Jupiter, Saturn, Uranus and Neptune played a pivotal role, flinging many of these bodies outward in a process known as gravitational scattering. While some were ejected into interstellar space, others were cast into distant orbits, forming the mysterious shell we now infer as the Oort Cloud. In the quiet of this moment, reflect on the gentle dance of forces that shaped this extraordinary realm. It is a testament to the universe's hidden grandeur, a whisper of the vast unseen wonders that lie beyond our view. And as you drift into deeper rest, let the mystery of the Oort Cloud be a gentle reminder of the infinite depths of our cosmos. This mysterious veil, the Oort Cloud, is a testament to the sculpting forces of the cosmos. Imagine icy bodies flung far from the Sun, caught in a gravitational tug-of-war. They orbit in a delicate balance, thousands of astronomical units away, yet still tethered to our star's gentle pull. But other forces quietly reshape these distant travellers. Picture the galaxy's tidal influence and the gravity of passing stars softly nudging these bodies, slowly transforming elongated paths into the spherical orbits we recognise today. Over countless millennia, this subtle dance has turned a scattered disk into a vast spherical cloud. The galaxy itself has shaped the Oort Cloud, explaining its round form and icy nature. These objects, born in the chilly outskirts of the solar system, were once flung outward by the giant's gravity. Now they dwell at the edge, barely held by the sun's reach. Closer still lies the inner Oort Cloud, or Hills Cloud, named after astronomer Jack Hills. It begins around 2,000 astronomical units from the Sun and stretches to about 20,000. Unlike its outer counterpart, this inner realm is denser and more disk-like. Here, objects remain somewhat bound by the Sun's gravity, less scattered by galactic tides. This dense inner shell may harbour more material than the outer cloud, yet its proximity means fewer comets are sent sunward. Visualise the solar system as a series of nested shells. The Kuiper Belt sits nearest, a flat, icy band from 30 to 50 astronomical units. Beyond, space thins out until the inner Oort Cloud appears, leading to the vast outer shell. Each layer holds secrets from the solar system's infancy. The composition of these objects offers clues. When comets from the Oort Cloud journey inward, their ices release gas and dust, revealing a mix of water ice, frozen gases, and organic molecules. This hints at the primordial building blocks of our solar system and possibly life itself. Trapped in a deep freeze for billions of years, these bodies are pristine time capsules from the dawn of creation. Contemplating the Oort Cloud's depths, one wonders about unknown giants like the speculative Planet 9, perhaps lurking within. Though undiscovered, such possibilities remind us of what lies beyond our sight. The Oort Cloud, shaped by cosmic forces, whispers of the vast, unseen wonders awaiting us. As you rest, let this celestial boundary inspire dreams of exploration and discovery, a gentle reminder of our place in the grand tapestry of the universe. Finds its home within a mere 30 astronomical units from the Sun. But the Oort Cloud, a vast and mysterious frontier, stretches far beyond this. Imagine it as a sprawling sphere of icy bodies enveloping the solar system, extending up to 100,000 astronomical units away. This distance is not just a number, it is a journey that redefines our sense of space. Picture a star drifting close, its gravity gently nudging the outermost edges of this cloud. Occasionally it might send a cascade of comets inward, potentially reaching the inner solar system. Some scientists speculate that such events could even correlate with mass extinctions on Earth. This idea, while intriguing, remains a topic of debate, yet it serves as a reminder of the delicate balance at the solar system's boundary. But stars are not the only actors in this cosmic dance. The Milky Way itself, with its spiral arms and dark matter halo, imposes a subtle tidal force. Though weak at the Oort Cloud's distant reaches, these forces can alter orbits over millennia. As the Sun orbits the galactic centre, it occasionally passes through denser regions or encounters massive molecular clouds. These encounters may trigger episodes where more comets dive inward, each carrying stories from the distant past. Imagine a long-period comet, once a frozen body at the edge of the Oort Cloud, stirred by a gentle push. Over millions of years it drifts towards the Sun, passing through the vast emptiness that lies beyond the Kuiper Belt, past the orbits of Neptune and Jupiter. As it nears the Sun, its icy surface warms, releasing gas and dust. A luminous tail forms, visible from Earth, a fleeting visitor from the farthest reaches of our solar system. This journey tells us something profound, something Jan Oort realised long ago. The solar system is vast, its boundaries indistinct, its reach extending towards the stars. The Oort Cloud, though unseen, is a testament to this grandeur. It is the solar system's hidden architecture, a relic of ancient times, reminding us that what we see is but a fraction of the whole. As you ponder these distances, let the immensity of the Oort Cloud expand your understanding of space, of where our solar system ends and interstellar space begins. Feel the wonder of this unseen boundary that blurs the line between us and the stars, inviting contemplation and dreams of cosmic journeys. The vastness of the Oort Cloud truly reshapes our understanding of the solar system's boundaries. As you imagine this immense space, consider how our familiar solar system, with its planets and the Kuiper Belt, spans a mere fraction of the distance. The well-known region stretches around 60 astronomical units, while the Kuiper Belt extends a bit further to 50 astronomical units. Yet, even at its furthest, this is just the beginning. Beyond lies the Oort Cloud, a region so distant it begins at about 2,000 astronomical units from the Sun. Between the Kuiper Belt and this inner region of the Oort Cloud, there is an expanse of emptiness, a void nearly 2,000 astronomical units wide. Think of Voyager 1, the farthest human-made object, launched in 1977. After nearly 50 years of travel, it has reached only about 165 astronomical units. It would take another 500 years to reach just the start of the Oort Cloud. And that is merely the threshold. The Oort Cloud could stretch to 50,000 or even 100,000 astronomical units. At its current speed, Voyager 1 would need 14,000 years to reach the conservative outer edge, and double that for the furthest estimates. Imagine the vastness of time. 14,000 years ago, our ancestors lived in the shadow of the last ice age. To put this in perspective, consider light, the universe's speed limit. It takes light about 8 minutes to travel from the Sun to Earth and about 4 hours to reach Neptune. But from the Sun to the inner edge of the Oort Cloud, light takes more than 11 days, and to the outer edge, nearly 10 months. For the most distant estimates, it could take over a year and a half for light to make the journey. Picture a scaled diagram of the solar system. If it were 10 feet long, the region containing all the planets would occupy less than 1/25 of an inch. The rest would be the Oort Cloud, stretching toward the stars. This distant frontier reaches about a third of the way to Proxima Centauri, the nearest star outside our solar system. It blurs the line between our solar neighbourhood and the vastness of interstellar space. In this grand scale, the solar system emerges not just as a collection of planets orbiting a star, but as a sprawling cosmic structure reaching out toward other stars. As you ponder this, let your imagination wander through the silent expanses where the Sun's influence gradually fades, merging with the interstellar void. Now imagine if the closest star system too harbours its own Oort Cloud. The stretches of icy bodies from our solar system might almost touch those of another, forming a tenuous bridge of objects between stars. This space, though sparse, may be populated with fragments that drift between the gravitational realms of different stars. Unlike a well-defined border, the boundary between solar systems could be a gentle transition where the Sun's pull diminishes and another star's influence begins to take hold. Consider the vastness in numbers. The journey from the Sun to Neptune spans about 2.8 billion miles. Yet, to reach the outer Oort Cloud at 50,000 astronomical units, you would travel over 4 trillion miles. For comparison, driving this distance would require more than 17 million years. Even flying in an airplane, it would take over 1 million years. These are distances that dwarf human lifespans, resonating more with the age of our planet. Picture the solar system scaled down where the distance from the Sun to Earth is 1 inch. In this model, the Sun would be a tiny dot. Mercury would be less than half an inch away. Neptune, 2.5 feet from the Sun, marks the edge of the planetary system. Yet the Oort Cloud would stretch far beyond, 1.5 miles from the Sun. A journey across this model would mean crossing a tabletop for the planets, but a leisurely walk for the Oort Cloud's edge. Another way to grasp this scale is to imagine the distance to Neptune as the width of a single hair. The Oort Cloud then would extend 10 inches. The planets occupy a sliver, while the solar system's true breadth spans vast distances. The Oort Cloud's volume is staggering, 5 billion times that of the planetary region, yet incredibly empty. With possibly trillions of icy bodies dispersed, each object enjoys a solitude of hundreds of astronomical units. If you stood on one of these distant objects, the emptiness would envelop you. No nearby landmarks, just the distant glow of stars. Alone on a frozen fragment, you would be surrounded by an expanse of darkness, stretching for billions of miles. In this isolation, the true scale of the solar system unfolds, an immense silent structure, inviting you to ponder the vastness beyond. Yet, even in this profound isolation, the Sun holds these distant objects in a gravitational embrace. Each body, millions of miles apart, continues its ancient dance around our star. Imagine an object at 50,000 astronomical units from the Sun. It takes 11 million years to complete just one orbit. To put that in perspective, dinosaurs vanished 66 million years ago. Within that vast span of time, an object at the edge of the solar system would have circled the Sun a mere 6 times. Their movement is imperceptibly slow, so much so that these distant objects seem frozen in time. Now think back to Pluto, which orbits at about 40 astronomical units from the Sun. When the New Horizons spacecraft reached Pluto in 2015, it had been travelling for 9.5 years. To reach the inner edge of the Oort Cloud at 2,000 astronomical units, a spacecraft at that speed would need 570 years. Reaching the outer boundary at 50,000 astronomical units would take 14,000 years. To touch the farthest edges, 100,000 astronomical units away, it would take nearly 29,000 years. Even then, the Sun's faint gravitational pull would still be felt, slowing the spacecraft's journey. Consider the Voyager 1 spacecraft. In 2012, it crossed the heliopause at roughly 122 astronomical units. This was celebrated as its entry into interstellar space. However, the Oort Cloud stretches far beyond, up to 100,000 astronomical units. Voyager has barely begun its journey through the Sun's gravitational domain. Thousands of centuries will pass before it completes this voyage. From light years away, an alien astronomer would see our solar system as a faint glow. The inner planets would be a tiny, dense cluster near the Sun. The Oort Cloud, however, would appear as an expansive and sparse halo, the largest structure associated with our star. In terms of sheer volume, the Oort Cloud dwarfs the planets. It extends nearly 37% of the way to our closest stellar neighbour, Proxima Centauri. Imagine standing on an icy fragment at the edge of this cloud. The sky is a sea of stars, with the Sun appearing as just another bright point. Yet despite its diminutive presence in the sky, you remain tethered to this distant Sun, still part of the solar system. Here the concept of home stretches beyond imagination, inviting you to ponder your place in this grand cosmic expanse. And so, as you linger at the edge of this vast cloud, the idea of home seems to stretch into an endless void. This changes the way you think about distances in our universe. When we imagine travelling to the nearest star, we often think of leaving the solar system first. But the truth is more complex. The solar system extends a significant portion of the way to the nearest star. You travel through the solar system's outer reaches for a long time before finally leaving the Sun's gravitational influence, already partway to another star. The Oort Cloud redefines our concept of the solar system. It transforms a compact collection of orbiting planets into just the bright centre of something much larger. This vast sphere stretches across light years, blurring the line between our star system and the next. It contains countless icy bodies, each a frozen relic from the birth of the solar system, drifting so far that light takes over a year to reach them. This raises a profound question. Where does the solar system truly end? It's not as simple as drawing a line on a map. The solar system doesn't have a clear boundary. It fades gradually into the space between the stars, without a sharp edge or a definitive dividing line. This fading changes our understanding of what it means for something to belong to our star, rather than the galaxy. So where does the solar system end? It seems like a straightforward question. But the more we know about the Oort Cloud and the Sun's influence, the more we realise it's not simple. There are multiple answers, each valid depending on what you mean by end. Science forces us to think beyond everyday language. In our daily lives, boundaries are clear. You know where your property ends or where a country's border lies. But the solar system lacks such clarity. It has multiple boundaries, each defined by different physical processes. The first boundary is Neptune's orbit, about 30 astronomical units from the Sun. Many think of this as the solar system's edge, but it's only the beginning. Beyond Neptune lies the Kuiper Belt, and further still the Oort Cloud. Defining the solar system's edge at Neptune is like stopping at the first row of trees and ignoring the forest beyond. A more meaningful boundary is the heliopause, around 100 to 120 astronomical units from the Sun. Here, the solar wind meets the interstellar medium. Voyager 1 crossed this boundary in 2012, followed by Voyager 2 in 2018. They both recorded significant changes, marking a true physical boundary. In some ways, they had left the solar system, exiting the Sun's magnetic bubble. But gravitationally, they were still within the solar system, as the Sun's gravitational pull reaches much further. This brings us to the third boundary, the Hill sphere, the region where the Sun's gravity still holds sway over the gravity of the Milky Way and nearby stars. The solar system's gravitational boundary extends far beyond the heliopause, reminding us of the Sun's persistent influence. Here, the concept of home fades gently into the vastness of interstellar space, leaving you to ponder the true scale of the universe as you drift off into thought. The solar system, though vast, is not a static entity. Its boundaries stretch far beyond the heliopause, yet the Sun's gravitational pull, though ever weaker, continues to stretch outwards. Gravity, even at its most feeble, never truly vanishes. Imagine a universe with no neighbours, where the Sun's influence extends indefinitely. But we dwell within a galaxy, surrounded by the gravitational dance of stars and the Milky Way's tides. Picture the Sun's influence weakening as you drift further away. At distances between 100,000 and 200,000 astronomical units, the Sun's hold becomes tenuous, overtaken by the galaxy's gravitational forces. This is not a distinct line, but a fading boundary. Here, the Oort Cloud resides, a fragile region at the brink of the Sun's domain. Within this cloud, icy bodies linger, barely tethered, susceptible to the faintest nudge from passing stars or galactic tides. Consider how a star passing within a few light years can disrupt this delicate balance. Such encounters occur every 100,000 years, enough to alter the orbits of millions of Oort Cloud objects. Galactic tides too exert a slow, persistent force, gradually reshaping this distant realm. Even the massive clouds encountered as the solar system orbits the galaxy's centre can leave their mark. This region is not static. The Oort Cloud is gradually eroded by these cosmic forces, losing objects to the galaxy or drawing them inward as long-period comets. Over billions of years, what was once a dense, massive collection of icy bodies has been whittled down. Astronomers believe the original Oort Cloud may have held dozens or even hundreds of Earth masses. Now it likely contains only a fraction of that. This slow erosion suggests an intriguing idea. The solar system's defined edge is retreating. Over its lifespan, the Sun's gravitational boundary shrinks inward. Although imperceptible over human timescales, this gradual process reminds us that the solar system is not immutable. It evolves, shaped by the galaxy's influence, inviting you to ponder the ever-changing nature of our cosmic home. As you drift into thought, let this contemplation of vastness and change gently guide you toward rest. This realization invites a new perspective on boundaries. The solar system, as we've seen, doesn't have a definite edge. Instead, it gradually merges into the cosmic backdrop, much like the gentle transition from warm to cool as you move away from a campfire. Imagine travelling outward from the Sun. You pass by planets, then through the icy realm of the Kuiper Belt into vast stretches of sparse space. Eventually you reach the Oort Cloud, a distant halo of icy bodies. Here the Sun's pull weakens, and beyond this the solar system's influence fades like a whisper in the vastness. But what lies beyond this boundary? Interstellar space is not empty. It's dotted with countless icy and rocky objects, remnants of planetary formations from other stars. In recent years we witnessed two such wanderers, Oumuamua and Comet Borisov, briefly enter our solar system. They are visitors from afar, likely ejected from distant star systems, confirming that space between stars is a bustling arena of cosmic leftovers. The solar system's boundary is not a line but a blend, where the sun's influence wanes and the galaxy's presence grows. This challenges our common notions of inside and outside here and there. Just as Earth's atmosphere gradually fades into space, and the outskirts of galaxies dissolve into the intergalactic void, the solar system melds into the galaxy. This vast interconnected web is a reminder that our solar system is part of something much larger. Picture the galaxy as a sprawling city, with the solar system as one of its neighbourhoods, connected yet distinct. The Oort Cloud is the interface, a region where solar and galactic forces intertwine. And as the solar system orbits the Milky Way, it traverses different cosmic environments, shaped by the gravitational dance of stars and the galaxy itself. So when you gaze at the night sky, consider this. Each star may host its own Oort Cloud, a vast sphere of icy worlds. These structures stretch across light years, blurring the boundaries between star systems. Our solar system, far more expansive than textbooks suggest, is a testament to the complexity and wonder of the universe. Embrace this idea as you rest, knowing that our home is a dynamic, evolving part of the cosmos, connected to the galaxy's grand tapestry. Imagine, then, the grand expanse of our solar system, stretching far beyond the familiar orbits of planets. It is a vast, spherical domain of ice and silence, extending across countless miles. The sun's influence, far-reaching and subtle, continues past the known heliosphere, reaching outwards into interstellar space. This transition is not abrupt. It is a gradual fading as the sun's gravitational embrace loosens, blending seamlessly into the galaxy beyond. Picture the Oort Cloud, a distant realm where the solar system's boundary dissolves. It is not a delineated edge, but a gentle fade into the cosmic ocean. Here, light from the sun takes over a year to arrive, illuminating fragments that drift in near-perfect darkness. These icy bodies have orbited in silence for billions of years, tethered by the faint pull of gravity. Every so often a passing star or the whisper of the galaxy disrupts this tranquil scene. A frozen fragment, nudged from its silent orbit, begins a slow journey inward. It crosses immense distances, moving past the outer reaches of the Oort Cloud, through the Kuiper Belt and into the warmth of the inner solar system. As the sun's rays touch it, ices thaw and a glowing tail emerges, a comet visible in our night sky. This celestial traveller, a messenger from the solar system's edge, carries ancient stories. It reminds us that our solar system is far grander than the diagrams suggest. Beyond planets, there is an expanse that fades into the darkness between stars. A comet's brief visit is a bridge between the known and the unknown, a testament to the vast, intricate beauty of our cosmic home. So as you see a comet streak across the sky, know that it has journeyed from the distant reaches of the sun's domain, tracing a path through time and space. It whispers of a solar system that is ancient and endless, inviting you to marvel at the universe's complexity. And as you drift into dreams, let these thoughts settle gently, knowing that the universe holds more wonder than we can imagine. Sleep well under the vast starry sky.